Source: researchers from the Max Planck Institute for Astrophysics and University of Milano-Bicocca, published in Nature Astronomy. If you like my videos, subscribe my channel and press the bell icon to turn notifications on so you keep getting all the major advancements in science and technology. And don't forget to like and share this video with your friends and colleagues. Comments are welcome and open for discussion. For decades, astronomers have believed that the universe is threaded together by an enormous invisible structure known as the cosmic web, a gigantic network of filaments stretching across space and connecting galaxies over millions light years. Wow. According to modern cosmology, galaxies are not randomly scattered throughout the cosmos. Instead, they form along these vast hidden highways of matter, where gravity pulls gas and galaxies together into interconnected structures. Now, for the first time in history, scientists have captured the clearest direct image ever obtained of one of these elusive cosmic filaments, revealing an immense glowing strand of intergalactic gas stretching roughly 3 million light-years across space. The discovery provides one of the strongest observational confirmations yet of the large-scale structure predicted by cosmological theory, and offers an unprecedented glimpse into how galaxies grow and evolve across the universe. The filament observed by the international research team connects two actively forming galaxies that existed nearly 12 billion years ago, at a time when the universe itself was only about 2 billion years old. Light from this structure began its journey toward Earth long before the Sun, Earth, or even our solar system existed. After traveling across nearly the entire observable universe, that faint radiation was finally detected using one of the most advanced astronomical instruments ever built. The observations were conducted using the Multi-Unit Spectroscopic Explorer, or MUSE, mounted on the European Southern Observatory's Very Large Telescope in Chile. Even with such a powerful instrument, detecting the filament required hundreds of hours of observations because the gas making up the cosmic web emits an incredibly faint glow. What makes the cosmic web so important is that it may represent the fundamental skeleton of the universe itself. Modern theories suggest that about 85% of all matter in existence is composed of dark matter, an invisible substance that does not emit light but exerts gravity. Scientists believe this dark matter forms an enormous interconnected framework stretching across the cosmos. Ordinary matter, including gas, stars, planets, and galaxies, gathers along this invisible scaffolding. At the intersections of these filaments, galaxies form and evolve, while the filaments themselves act as cosmic highways that funnel gas into galaxies and fuel the birth of new stars. Until now, however, directly observing these structures has been extraordinarily difficult. Most of the gas in intergalactic space is extremely diffuse and emits only faint radiation, especially hydrogen, the most abundant element in the universe. Previous studies often relied on indirect methods, such as analyzing how the gas absorbs light from bright quasars or distant galaxies behind it. This new study changes that by directly imaging the filament itself in remarkable detail. Scientists were not only able to detect the glowing structure, but also precisely map its shape and distinguish the gas inside galaxies from the surrounding material flowing through the cosmic web. To better understand what they were observing, the researchers compared their measurements with advanced supercomputer simulations of cosmic structure formation. These simulations model how dark matter and gas evolve over billions of years under the influence of gravity. Remarkably, the observed filament matched theoretical predictions with striking accuracy. The agreement between observation and simulation strengthens confidence in current cosmological models and provides new insight into how matter flows through the universe on the largest scales imaginable. The discovery is scientifically profound because it reveals the mechanism by which galaxies may continue growing over cosmic time. Galaxies require enormous amounts of gas to form new stars, yet astronomers have long debated how galaxies continuously replenish this material. Cosmic filaments appear to provide the answer. They function as giant intergalactic supply channels, transporting gas across millions of light years directly into galaxies. By observing these structures in detail, scientists can begin studying how matter moves through the cosmic web and how that process influences galaxy evolution, black hole growth, and large-scale cosmic structure. The two galaxies connected by the filament each contain actively feeding supermassive black holes, making the system even more interesting. These energetic environments illuminate the surrounding gas, helping astronomers detect the faint emission from the filament itself. In a sense, the galaxies act like cosmic flashlights, briefly exposing one strand of the otherwise nearly invisible web that spans the universe. Perhaps most importantly, this breakthrough demonstrates that humanity is beginning to directly observe structures once considered almost impossible to detect. For years, the cosmic web existed primarily as a theoretical prediction supported indirectly through simulations and statistical evidence. Now, astronomers are finally seeing its architecture in high definition. The universe is revealing not just isolated galaxies and stars, but the gigantic hidden network connecting everything together across cosmic distances. Researchers are already planning further observations to identify many more filaments like this one. By mapping additional regions of the cosmic web, scientists hope to build a far more complete picture of how matter is distributed throughout the cosmos and how galaxies interact with the enormous invisible framework surrounding them. Every new filament detected brings astronomy closer to understanding one of the deepest questions in cosmology: how the large-scale structure of the universe emerged from the aftermath of the Big Bang and evolved into the cosmic landscape we observe today. The discovery also carries a powerful philosophical implication. On the largest scales, the universe is not chaotic or random. Instead, galaxies are woven together into a vast interconnected network spanning billions of light years. Hidden beneath the darkness of space is an immense cosmic architecture, a structure so large that entire galaxies become merely tiny nodes within its gigantic web.